Okay, now let's talk about integration. So again, just like differentiation, we'll talk about a few formulas, we'll talk about some applications, and then we can directly talk about the questions. Okay. Right, so first thing is that how do we denote integration? For this, let's say if f of x is a function and you are to integrate it, so we write it down this way: integration of f of x with respect to x. Okay, this is a very basic thing, and we know that the opposite of differentiation is integration. Now we need to understand how to integrate functions. So let's talk about that quickly. It depends on the function. Let's say you are to integrate x to the power n with respect to x. So it's the opposite of differentiation. So x to the power n plus 1 divided by the new power plus c. So in integration, we are always supposed to add the constant. Let's talk about another one. Let's say now you have a bracket ax plus b to the power n with respect to x. And for this, ax plus b would come as it is. The power would become n plus 1 divided by n plus 1 and multiply it, or basically divided by the derivative of
Yeah,
this function. So the
right.
derivative is a. So we are just going to divide it by a.
Let's
Okay.
see.
Yeah, plus c. Very good. And then let's say if you have an exponential function e to the power mx with respect to x. So for integrating this, e to the power mx would come as it is. And instead of multiplying it by the derivative, we are going to divide it by the derivative, that is m plus c. And then if you have a logarithmic function, sorry, for logarithmic functions, we use integration by parts. If you have another exponential function of this type, we are going to do it this way: a to the power x divided by ln of a plus c. And then the last one is integration by parts. That is if you have a product.
Wait,
Hmm.
for part four, AX, shouldn't it be one?
Hmm.
Okay, just give me 1 minute.
Sure, sure,
Okay.
sure.
Yes, for part th 4 for
Hmm.
Linux, right? If the equation was 1 by ax plus b, then we would have converted into ln on the mod of ax plus b or a. Oh, this is for the single term, not for the bracket, right?
Yes, yes. You're talking about the fourth part?
Yes, I'm talking
This
about the
one?
fourth part.
Yes, we have a to the
Yes,
power x, and when you are to integrate this, this is what you get.
ax over ln a. And if this were ax plus b
Hmm.
into some power, then,
Wait
or
a
maybe
second.
just one.
Wait, tell me
One,
the expression again.
okay, 1 divided by
1 divided by
ax plus b,
a into x or a to the power x?
ax
Ax.
plus b
Hmm. I got your point.
This is yeah.
Yes, okay, okay. For
Now we
such,
have to integrate this.
yes, you have to integrate this. Okay, so for this, we use that rule. We'll be talking about that shortly. You know, where you have the derivative in the numerator and you have the function in the denominator. So you can think about it this way, that let's say you have a and you are just doing it this way. So now we will use natural log, and it would be 1 by a and natural log of ax plus b, right?
Right.
So this
That's
is completely
exact.
different thing. Okay, this thing and this is very, very different. We have a to the power x, and here you have this function whose derivative is there in the numerator, which is not there actually, but we are just making it by dividing that as well.
Right. This is very strange because in P3 we
Hmm.
didn't do the single term, but we did the bracket, and they should have, you know, taught us this as well.
No, basically this is no, no, no. I'll tell you. You know what? In for the NET syllabus, we're talking about the FSC maths, and it has more to memorize. So you'll see once you're done with your P3, when you'll start preparing, if you plan on going to NUST. So you will see that you would
Mm.
have to memorize more. So you would be investing more there rather than focusing on the concepts. So that is what works
Okay.
for this thing. Although once you enter NUST, honestly speaking, concepts work and you won't be memorizing too much stuff. It's not like that. But yes, for FSC and for the entry tests, it is like that.
All right.
Okay. So yes. And then the last one is very important. You would be knowing that if you have a product, U into V, and you are to integrate this. So you know that we do it by parts. We have a rule for this. So first comes as it is, and then we integrate the second one. I'll tell you how to choose the first and second. Then minus sign, integration, in this thing would come again inside, integration of v with respect to x, and then the derivative of the first one with respect to x. And if you are not able to understand because of these horrible signs, so you can think about it this way, that if you have two functions, first would, oh, this is not very obvious, 1 second only. First function is coming as it is, then you are integrating the second. Let me write it down somewhere else. Right, so this is the first function and it would come as it is. For the second one, you need to integrate, then minus sign, then integration sign, then the integration of the second one, the derivative of the first one, and dx. Okay, so at times students are not able to understand the integration, but always remember, if you have two functions of x and they're being multiplied, it could be that one of those functions is algebraic, the other one is logarithmic, both the functions are trigonometric. It depends obviously, but for integrating that, you can use by parts, integration by parts, and first function would come as it is. You need to multiply that with the integration of the second one, then minus sign, integration sign, integration of the second one as it is, multiplied by the derivative of the first one. Now, how to choose the first function? That is a good question, that how do we choose the first function? So we use a rule that says I, L, A, T, E, and this is for basically choosing the first one. So it's inverse, this is logarithmic, this is algebraic, this is trigonometric, and then this is exponential. Okay, we will be practicing questions, but for these questions, we are mostly using a bypass whenever you have something of this type. Let's say x into cos x, stuff like that. When you know that this would be, when you know that this function or the first function would be eliminated by integration, only in those cases, by differentiation, only in those cases we prefer by parts. Okay, otherwise we have multiple methods. I'll be talking about more methods shortly, but yes, this is the idea. So are you okay with this?
Yes, very questionable. Okay,
Hmm.
let me just take a screenshot. Okay, done. Let's go to the next
Okay,
concept.
so I'll just erase this and we'll talk about the next things.
Maybe we do the integration of the product view of the product
Hmm.
variables in P4. Maybe
No, like, but
that's
I
okay.
in P4.
Yeah, P4 it has integration of higher level.
Mm-hmm. But I am teaching P3 as well, so like we use integration by parts.
What do you mean by parts?
But this method where you have product.
No, 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 no. I've I have literally done P3 every question. I didn't find any
Okay, I'll send you some
question of
questions
this
then. I'll
sort.
send you some questions. Don't
Really?
worry. Yes,
From P3?
yes, from P3, Cambridge board.
Math? Which syllabus? Cambridge board? No,
Yeah,
Dexel. I take a Dexel math.
you are from Edexel.
That's why. Yes, that's the reason. No, no, I
Okay.
take my physics and my computer science is
Mm-hmm.
from Cambridge board, but my math is from a Dexel.
Yeah, obviously. Then if the board is different, there are
Right,
many
right.
many differences. Obviously, yes. No, I'm talking about the Cambridge board. I'm
Okay,
teaching AQA board AS maths and then Edexel board O level maths. But yes, obviously if the
all
board is
right.
different, then certainly you would it's it would be true if you're saying so. But I was just concerned because you'll be appearing soon, so I just wanted, if there's something which you have missed, so I
Right.
can just share that. Anyways, let's talk about some trigonometric functions in that case. So if you have sine x with respect to x, the integration would be minus cos x plus c. If you have cos x with respect to x, the integration would be sin x plus c. And then if you have secant square x with respect to x, so the integration is going to be tan x plus c. Right, and I will add a few more over here. So therefore the trigonometric ones, we have more as well, but I'll be just talking about those which are used a lot. And then for the inverse trigonometric functions, so let's say we did a similar thing for derivatives as well, so you would be able to memorize this. This would be sine inverse of x. And then let's say we have 1 over x squared plus a squared with respect to x. This is going to be 1 by a tan inverse of x pi. This is what I was telling you yesterday. We use this rule in B3 for integrating such functions. And
Okay.
yes, okay. So, but the only thing which you need to understand is that, at times students just mix this up. The integration of sine is minus cos and the integration of cos is positive sine. Okay, just be careful with the signs. For secant square x, you have tan x. And if you have something of this type in the integral, one for the NET maths, they would not test you for some difficult concepts. Not at all. The questions would be simple, but they would require your memory. Like, it could be that they are giving you something of this type. So it is totally on you. If you were to memorize all the formulas very well, then you would be able to do it. Okay. Otherwise, they would not give you something very, very difficult or out of syllabus. The concepts are going to be from what is given in the book, but you need to memorize everything, because calculations without calculator, without formulas, makes it very difficult. Otherwise, it's not that difficult. Okay. So, yes, this is something which you should know. And then the last thing is this one, which we were just talking about, that if you have something of this type to integrate, there's a fraction, and in the denominator, you have a function, and the derivative of that function is in the numerator. Okay. So for such questions, you do ln f of x plus c. Now, it's not necessary that you exactly have the derivative in the numerator. It could be that you have the variable, but you do not have the exact same coefficients. You can make the coefficient by yourself by multiplying it in the numerator and then dividing it as well. As maths, as long as you're balancing everything, it is mathematically correct. Okay. So, are you clear with this one?
Divided by the f of x, f dash of x. No,
Divided by f of x. For example, let's say
no, no,
this
no, no.
was
In the is equal to ln
natural
mod of
log of
f of
f of
x,
x plus
right?
c.
And not gonna divide it by f dash of x.
Sorry, I was not able to understand. Can you please repeat?
Will be not divided by f dash of x.
No, okay, wait. This
The
this
answer.
this was the
Okay.
question which you just gave me. Ax plus b, right? 1 divided
Hmm.
by ax plus b. So this is the function, and the derivative of this function is a, which is not there initially. So I'll just multiply a in the numerator and I will divide it as well. And now if I integrate it, what do I see? This is f of x, and this is the derivative of it. So I can do it this way. 1 by a would come as it is because it's outside the integral sign, natural log, and then ax plus b plus c. Yes, is that okay?
Yes, it's okay.
You can ask me again. I would not mind that. Okay, if your concepts, if you are not able to, because I do realize when I was, I gave NET2, and I had to give my CIEs in, like, less than 20 days, and I started preparing for this math. So every time this same happened with me, I was trying to link my concepts with P3, and this was also happening with me. So it's completely fine. If you have any questions, just ask me. I would be able to answer you.
All right. Okay.
It's okay.
Yeah, it's okay.
Okay. Then the last thing is the definite integrals. That's easy. These are the indefinite ones. We were not writing down the limits. And if you write down the limits, we just need to plug in the values and subtract them. So let's say you have AB f of x dx. Okay. So let's imagine that after the integration of f of x, the function becomes capital F of x. So we write down the limits this way, a, b, and the final answer is calculated this way. We plug in b, the upper limit, minus sign, and then the lower limit. So in short, this is the function. Just integrate it. You will get another function. We are writing it as capital F of x. The limits were a and b. Plug in the upper limit, put a minus sign, and plug in the lower limit and find the difference, and that would give you the answer.
Okay.
Is that okay?
Yes, it's okay.
All right. Okay. And then if we talk about the applications of integration, so you would be knowing when we differentiate a curve, we get the slope at different points, we get the derivative, we get the gradient. And when you integrate anything, you get the area under the curve. Now it depends. Let's say
Yes.
sorry, let's say you have a curve phi. I'll just explain this way. Something of this type, okay? And you are interested in this area. So the curve is f of x. You are supposed to integrate it with respect to x because this is the x-axis and this is the y-axis, and the limits would be 0 to a, right? You would be familiar with this already. Yes, Ahmed, is that okay?
Yes.
And now let's say it's other way around. You are to integrate again, but this time around the area is bounded between the y-axis and the curve. And this is the area which you are interested in finding, okay? And again, this is f of x equals y. So step 1 would be making x the subject and finding f of y. Once you have f of y, you're supposed to integrate that with respect to y, and the limits would be 0 to a. Always remember, whenever the area is bounded between the y-axis and the curve, you would be having dy here. This would be f of y, and the limits would be from the y-axis. Okay, so everything would change. Otherwise, it would have been f of x dx, 0 and a, but this time around, since it is between y-axis and the curve, so we have y here. Yes, is that okay?
Yes, that's okay.
Okay. Now let's say the last thing is you have area under two curves. So basically, this time around, we were talking about a curve and the axis. Let's say you have two curves. This is a line, and then you have a curve as well. Something of this type, okay? And this point is A, and this is 0. And you are to find this area. So what do we see? We can see that this is f of x and this is g of x. F of x is greater than g of x because it is higher than the line, the green line. So you will integrate f of x minus g of x with respect to x from 0 to a. This is how the rule changes. If the area is between two curves, you will find the difference of the two curves first, and then you are going to integrate it and plug in the limits. Yes. Is that okay, Ahmed? Yes. Any confusions with this?
Oh, sorry, I was muted. Yes. If the lower part was shaded, then what?
Okay.
Then
If the lower
we will.
part was shaded, then we would just forget f of x and we would have integrated g of x directly. Okay. let's say this was the question.
Yeah, okay.
Okay,
Got it.
this one. So you will just
And
integrate
then
it directly.
subtract it.
No, if it,
Yeah,
it
and then
if it was
subtract.
g of x only, so you would have done it this way: integration of g of x with respect to x from 0 to a.
Okay, right.
Okay. Also, Ahmed, did you study differential equations?
Okay, I may not be like differential equations.
I'll
Can you
tell
show
you.
me what they
Yeah,
are?
yeah, yes, yes.
Right. I may have forgot the term name, but
Where we are basically using, where you initially have differentiation, where you have a derivative given, and you are to find the equation. So let's say dy by dx equals x squared plus 2.
right. Then integrate this to
Y-
find
Yes,
f of
yes,
x.
very good. Yes, okay. So you know how to do it. Okay, all right, very good. Then then there's another thing for differential equations. Since we have some questions from that part as well, degree and order of a differential equation. So order is basically this, that if it's a first order derivative, if it's a second order derivative or third order derivative, right? Like if you have dy by dx, or if you have d2y by dx2, or if you have d3y by dx3. So this is basically the order of differentiation, and this degree is just a simple degree um, of the differential equation. Let's say if I have y equals x squared plus 1, the degree of the equation would be 2. If you have y equals x cubed plus x squared plus 2x, the degree would be 3. We are focusing on the highest power of x. Similarly, if I talk about a differential equation, it would something of this type. So you would be having some numbers here or anything, could be anything. Let's say you have dy by dx squared plus dy by dx equals 1, for example. Okay, so the degree of this equation is going to be 2, because now I'll think about my variable as dy by dx. So whenever the question is about degree, you'll talk about the outside power. Okay, and when it's about order, we'll look at this number right here, and you will see we'll be talking about multiple questions of this type where you need to identify the degree and the order of same equation. So let's say if you have this thing, let me write it down: dy by dx to the power 3 plus this dy by dx equals 1. Now you need to find out the order and the degree. So for the order, we look at the highest order of the derivative. It has first order, it has second order. So the order is 2 and the degree is 3. For the degree, we are looking at the overall power of the variable, and for the not of any variable, of the highest order derivative. Okay, so first you identify the order, that would be the order of the derivative, the highest order of the derivative, and then you need to look at the power of that would be your degree. So that is 3. Yes, were you able to understand this?
Yes. Yes.
Okay, all right. So it's good that we are done with this. More concepts would get clear with questions. I am going to share the PDF again. Okay, let's talk about some of the questions. So trust me, it's very easy and you would be able to do it by yourself as well. So the first one says the integration of 1 by x squared. So I'm pretty sure even from P3 you would be knowing that the choice of the method depends on your function completely. So what do we see? We can write it down as integration
B.
of x to the power minus 2. Sorry, say it again.
Would it be B?
I was not able to hear you.
It should be B.
D? No, it's not D.
B. 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 B.
B. No, I'll tell you why.
B for ball.
No, it's not B, because you do not have the
Okay.
derivative of x squared in the numerator, right? You can only do this if you have the derivative of the numerator, of the denominator in the numerator. The derivative of the numerator would be 2x. You do not have 2x in the numerator, you just have 1. So it cannot be natural log x squared.
So just shift it up and
Yes, it's simple integration, okay?
yeah, so that
So
is
this is
simple
going to give
integration.
you, we will add 1 first, minus 2 plus 1. We are going to divide it by the new power, that is minus 1. So this would turn out to be minus 1 by x. The answer would be C. Yes, is that
Right.
clear?
It is cleared.
Okay. Now for the 17th question, you need to integrate g of x with respect to x, and then they are differentiating it as well. So since we know that integration and differentiation, they are opposites of each other, so
Until
the
the
answer would be the function directly, right?
A.
A. Very good. Very well done. Okay. Now the 18th question is very, very interesting. It says x plus 4 divided by x plus 3. Now, if you think about all the methods, you can see it's not a product of two functions, so you cannot use the integration by parts rule. You can see that you cannot find the derivative of the denominator in the numerator. So how are you going to do this? Okay. So I'll tell you. First of all, always try simplifying the function whatever way you can. So you can write it down as, you can write down x plus 4 as x plus 3 plus 1. Okay. It's just simple logic. It's no method. It's just simple logic that x plus 4 can be written this way, divided by x plus 3. Now I can divide this x plus 3 separately. I can write it down as x plus 3 divided by x plus 3 plus 1 divided by x plus 3. This x plus 3 and x plus 3 can be cancelled. This would give me 1. And finally, the simplified function is 1 plus 1 by x plus 3, and I was supposed to integrate it. So step 1 of any integration function would be similar, simplifying the function, just so you
D
know
would
how
be
to
the
integrate it. Sorry,
answer.
D?
Not D, sorry, C.
Yes, very well done. Excellent. Very good. Okay.
But
Hmm.
we could have done that directly without simplification as well. Though it would have taken more time, but just shift x plus 3 up, minus 1 would come, integrate the both. No?
No, whenever you have x to the whenever you have 1 by x or anything with the power 1, you cannot take it to the numerator, because you know what, you would get rid of the function. When you will add 1 to
Mm,
minus 1, that would give you 0 in the power, and it would give you 1. Okay.
right.
Right? So always remember 1 by x, 1 by x plus 1, anything of this type that has 1 in the denominator or
That
minus 1 in the numerator, you're not supposed to integrate it by using the
yeah,
simple method.
got it. So x plus 3 would have been, the ln would have it would have become ln x plus 3, and then x plus 4 would have been left, and
No, you
okay,
cannot do it that way.
yeah, we can't. Okay,
Okay.
all right.
So this is the way of doing it. So yes, it's good that we think about all the methods. Obviously, that is very good. Because in exam we are not sure what the question would be, so it is the best thing. Always try thinking about different type of situations. Okay, but for this
Is
one,
there any,
hmm,
right? Is there any divide rule for the integration?
no, it's for differentiation, the quotient tool, but it's not there
Okay.
for this. Okay. Okay. Right. So, but it was easy, right? You can just modify the function and do it this way, and you were able to do it this way directly. This would be the answer. Very well done. Okay. No doubts with
Mm,
this?
no doubts.
Okay, all right. Let's talk about the next one. That is this one. Okay. Now you need to integrate this. So what do you see? This is x and it's being multiplied with cos of x. So what method
Divide.
should we use?
Sorry.
Mhm.
Sorry. Product
Yes,
rules
very good.
integration.
Yes, very good. Okay. So can you tell me what would be the answer by thinking about it first properly and then just, telling the answer? You would be able
Yeah,
to
the
identify the
formula.
answer in the options.
But the formula,
Okay, okay.
I
The
need to
formula is
go back
basically,
and
so if you have two functions and they are being multiplied, so first comes as it is, the integration of the second one minus integration sign. This integration of the second one would come again and you need to multiply it by the derivative of the first one with respect to x. And ILate is the thing with which we identify the first function, that would be u. Just take your time and then think about it.
okay. Which one is you chosen? Which one is B? U is X cos, right?
U is x.
Oh, right. It's not X cos. It's cos X. Sorry. I'm just sick. Okay. So, so we'll differentiate. Sorry, integrate X first, right?
Okay, wait, let's do it together. This is algebraic and this is trigonometric. A is coming first, so this means that this would be the first function. U is going to be x. Okay, so x would come as it is, and then the integration of the second one. Cos x is the second function. When we integrate cos x, that would give me sin x. Then minus sign, integration sign, and then this thing would come again. That turned out to be sin x. And now I need to multiply this by the derivative of the first one. The first one was x. The derivative of x is 1. So this would become x sine x minus into the integration of minus sine x would be minus cos x. So it is going to be x sine x plus cos x and it would be C. Yes. Were you able to understand this?
Yes.
Okay. All right. Let's talk about the next one. Let me just you can do this one now because we just discussed something of similar type. Okay, it says the degree of the differential equation. Now they are talking about the degree.
Yes. So
So I'll
two,
tell
right?
you. I've told you earlier as well, when they talk about order, we look at this thing, okay, the highest order. And when they talk about degree, We do not look at the
1,
degree of
2.
dy by dx. We look at the degree of the highest power of the highest order derivative. That is 1.
No, it's 2.
No, it is 1. The degree of the highest order derivative. Okay, the highest order derivative is d2y divided by dx2. So it is 1. That is why the answer is 1.
No, what's that 2 supposed to do then?
This is just the degree of dy by dx, okay, but it is not the degree of this differential equation.
Okay, I am
I'll
super
read the definition from
confused.
the book. I'll read the definition from the book again, so it would make more sense. The degree of the differential equation is the degree of the highest order derivative that appears in the equation. So the highest order derivative is what? It is this.
Okay,
Okay.
okay, all
So
right.
we will be talking about its degree.
So if there was d3 y by dx3, we would have looked for that power.
Exactly. Yes, exactly.
Okay.
Very good. Very good. Okay. That is why the answer is A. Even I got confused with this one, but yes, this is how it is. Always look for this thing, and it is an important question. Right. So let's talk about the next one. You can try doing this one. Solution of the differential equation dy by dx equals sine x by sine y. So we discussed this. It's a differential equation. We will be separating the variables. I can take sine y there and I can take dx there. So sine y into dy equals sine x into dx. Now we are supposed to integrate it. So the integration of sine y would be minus cos y equals minus sine y plus c. This is going to be the answer. Sorry, this would be cos. Okay, and now we are to simplify this. So you can simplify this, and this is going to give you, I can take cos to this side. This would be cos of x minus cos y plus cos x equals c. Now, if you look at all the options, we are not able to find anything of this type. So we need to multiply a minus on both sides. Okay. So this would give you cos y minus cos x equals c. There's no point in writing down minus. You can write down minus c or you can write down c. By now you would be knowing that sine and everything is absorbed in the constant. Okay. So minus c can be written as c or any other constant, right? We don't write down minus with the constant. You know this concept?
Now I know.
Now you know. Okay. So the answer would be D. Okay.
Okay.
Are you sure that you're getting all of this, Ahmed?
Yes, and even if I forget, okay, I would have a month to prepare.
Yes. Okay. That
Just
is a good
enough.
answer. That is a good answer. Okay. All right. So yes, you can try doing this one. The slope of tangent to the curve this at P11. So slope of tangent, the equation is given. How do we find the slope? By differentiating dy by dx would be 2x minus 2. We plug in the value of x. This is what you were saying that you have only seen these cases. So 2 into 1
Yes.
minus 2 and this would give you 0. So the answer is going to be B.
Okay.
All right, let's talk about the next one. Now it says the area bounded by the x-axis and the curve of this is the curve, and you need to find the area bounded by the x-axis and the curve. Now we can clearly see that all the options are numbers. It means that it would be a definite integral. You need to apply the limits as well, and we know how to integrate because it would be a curve. It is negative x squared. So whatever the function would be, it would be a curve, and then it would be something of this type. And we need to find this limit and this limit, and this would be the area. But we do not have the limits. So how can we find the limits?
Negative x squared gives a minimum. No, it
Gives a
gives a
maximum
maximum,
value,
right?
right?
Gives a maximum. Yeah.
So
So what's the area
the
bounded by the x-axis,
yes.
and the curve y is
So we are interested
okay.
in
So
the
it's
limits basically. So what would be the
right.
limits?
So the limits will put y is equal to 0 to find
Very
x.
good. Very well done. 0 equals 4x minus x squared. So I can take x common and it would give me 4 minus x, and x would be 0 and it would be 4. So it's 0 and 4. And now I can integrate it from 0 to 4. The equation is minus x squared plus 4x with respect to x. It would give me minus x to the power 3 by 3 plus 4x squared by 2, and no point of writing down the constant in the cases where we have definite integral. And when you simplify this, the answer is going to be 32 by 3. Let's do it. So first we'll plug in 4. I'm plugging in the values here on the other side. So minus 4 cubed by 3 plus 4 into 4 squared by 2, and then minus 0, because it's 0. When we'll plug in 0 here and here, it would become 0. So 4 cubed is 64 by 3 plus 64 by 2. Okay, and now we need to simplify this. So the denominator would become 6. I need to multiply 64 by 2, and I need to multiply 64 by 3. So minus 64 by 2 into 2 plus 64 into 3. Sorry about this. Plus 64 into 3. So no need to simplify things. It would become, I can take 64 common. So this would give me minus 2 plus 3 divided by 6. And now I can just cancel this out. So it's 2 into 3, and it would become 32. So 32 divided by 3. The answer would be A. Now you can see clearly I just did minimum working. I did not use my calculator for this. So I just used some logical things. I did not make things difficult for myself, and I was able to solve this, right?
Okay.
So is that okay then?
Yes, that's okay.
Okay. Let's talk about the next one. It's easy. It says if f of x is this, then f of 3 would be f of x would be what? We need to find that first. So integration would give me this. These are the limits. So this would be this again, x cubed by 3. And for f of 3, I need to plug in 3. So it would give me 3 cubed by 3, and that would give me 9. So the answer is going to be A. Right.
Yeah.
This was
Okay.
the
Sorry.
next one. This was the next question. F of x
Okay.
was equal to this, and you need to find the value of f of 3. So first we need to find f of x. It's simple integration. I integrated it. I just plugged in the limits 0 and 3. When I'll plug in x, it would give me this, and 0 would give me 0. Once I got f of x as this, I plugged in 3 and it gave me 9. So the answer would be A.
1 second. Sorry. I
Yes, sure,
was
sure.
okay. My sir just texted me and I had to reply him back. Okay. Uh, so you integrated. Can you repeat the steps? I'm really sorry.
Hmm. X squared was integrated and
Okay.
it gave me x cubed by 3. And then we were looking for f of 3. So I just plugged in 3 instead of x.
Okay.
So this is where I
Okay.
plugged in 3 and it just 3 and 1 from the power was minus and I got 9. I got 3 squared, that would be 9.
Nice. Okay.
Right.
We did 44 questions.
No, we did not do 44 questions. We
Yeah.
I don't
Okay.
do all the questions. I just pick up some questions. So we are just left with 2 more questions and we have 4 minutes. Let's do them. Let's do it quickly then, okay? This
Okay.
is important. So it says order and degree of the differential equation. We need to talk about this one. So again, you please think about it.
1 second. Will end in 5 minutes. All right. Yes. Okay. The order and degree of the differential equation is this. Okay. What is that? Is equal to d to y respectively. Okay. So what do order and degree of the differential equation?
Right.
So what
So
do I have to do?
okay. So for order and degree, the order is basically the order of the derivative. Here it is 1
Okay.
and here it is 2. Okay. So it is going to be 2. The order would be 2 because we are looking for the highest order, right?
And the degree?
Yeah, the
Would-
order is going to be 2. And for the degree, you need to, this is what we discussed earlier as well. For the degree, we need to talk about or we need to look at the degree of the highest order derivative, okay, as per the definition. So this is what we have. This is 1 apparently, but you can just shift this 3 by 2 to the other side, right? You can do it that way, or you can do it some other way as well, but the answer is not there in the option, so there is some problem with the question. Let me just check it quickly. It is the 50th question. Order and degree differential. Let me check if it's 3 by 2. The answer is, let me check the answer. 50th question. The answer is A, but there is something missing in the question. Maybe because of my book. Let me quickly see if there's something written in the book. Because I think there's some problem with the question because I think my book has some misprinting at this point.
Okay.
Yeah, so this would be, the answer would be A if the answer would be A if somehow we get the power of this thing as 2. Okay, this is what we just discussed. The degree of the differential equation is basically the degree of the highest order derivative. Okay, only then it would be 2. So there maybe there's some misprinting or stuff like that, but you know the concept, right?
Yes.
Okay, I'm sorry about this. Let's do the last. Let's do the last one. It's more important. This one is easy. You just need to plug in the values. Cos x would give you sine x, and then just pi by 2 and minus pi by 2. But this one is more important. Okay. Now it says 5 minus 2 to the power x. So we have two functions and they're being subtracted. When you will integrate it, you would get 5x for the first one. And for the second one, what do we get? So I've told you earlier as well, this is where you got confused. It is going to be 2 by x coming as
2x
it is.
as it is,
Very good.
right?
ln 2 plus c, right? So this would be the answer.
Okay, why is ln in the denominator?
Because this is how we do it. I told you the formula when we were talking about it. Do you remember the formula where you got confused, where you gave me that thing ax plus b in the denominator?
Okay.
So we are basically going to use that formula.
Why
Yes.
aren't we gonna use the,
Hmm.
oh, that's for exponential functions, okay.
This is, the formula for exponential function is also coming from here. That formula is also same. I'll write it down once again. The rule, this was the rule we were talking about. A to the power x dx, and this was a to the power x divided by ln of a. Okay. So when you are integrating e to the power x, you're also doing the same, e to the power x divided by ln e. But since ln e gives you 1, that is why we never think about it this way. Otherwise, you are also doing it this. It holds for all the exponential functions.
Okay.
This is also exponential, and this is all, both of them are exponential because we have an exponent that is a variable. Okay. Yes. So any doubts?
Just 1 second, let me
Sure, sure.
put it to speaker. Yeah, no doubts.
Okay, all right. So I'll stop sharing the screen.
Okay.